It's your friendly math tutor, Miss C here, and today we are creating a table of values for a quadratic function. I know this function is quadratic because the highest degree or the highest exponent is 2. So what we know about quadratic functions is they have either a maximum or a minimum point, and they generally either have a shape of an upward facing U or a downward facing U. So before we get started, I'm going to notice something really important right here. My x squared term is negative. That means that this parabola or this quadratic function is reflected, which means that the vertex is a maximum. I've got a whole series of videos on this, but this is going to be important for when we make our table of values to make sure that we don't make an error. All right. I'm going to go ahead and set up my t-table because essentially when we make a table of values, we are finding every y value for the x values that we put in. Quadratics are a little interesting, and before we make tables of values, it's really good to know what our general shape is, because what I do need to know is that I need to figure out where this maximum is. So the x coordinate of our vertex, because we are going to want to make sure that we have x values around that. So to find the vertex, we're going to use a little formula that looks like this, negative b over 2a. So remember, this is a, the term in front of x squared. This is b, and this is c. So what I'm going to go ahead and do, and this is from standard form, so I'll just write that up here. So our standard form looks like that of our quadratic function. All right, so to find our vertex, I'm going to go ahead and say negative. And then I'm going to put in my b, which is negative 4. So make sure you don't drop that negative, over negative 1. So I end up with negative 4, which is positive 4, over negative 2. Okay, so that gives me an x coordinate of negative 2. So I know that this is going to be my vertex. So I'm just going to note that here. And I'm just going to pick a few points around that vertex. So I'm going to go ahead and we'll do negative 3 and negative 4 and negative 1 and my favorite for tables 0. So let's go ahead and I'm going to go ahead and put 0. I'm going to erase this a little bit. It's a little cleaner to see. I'm going to go ahead and put 0 in everywhere I see x. I'm going to set this up for us so we could substitute really easily. Okay, so when I do that, I'm left with my c term, which is negative 1. Okay, now what I also know about quadratics, and I'll show you, is that they are absolutely symmetrical. So I should see a value of negative 1 exactly 2 units away from the vertex on this side. So let's just double check that that is true. This is the other power of knowing the vertex. So I have negative 4 squared is positive 16 times a negative, which is negative 16. I have negative 4 times negative 4, which is positive 16, minus 1. So that makes 0 minus 1, which is minus 1. So fantastic. So if I were doing this again, I would only find one side and take a shortcut. So we'll do that here. I always pick the best numbers too. So I'm going to use negative 1 next. So I have negative 1 squared, which is 1, times a negative, which is negative 1. And then I have negative 4 times negative 1, which is positive 5, or positive 4. Okay, so negative 4 times negative 1 is positive 4 minus 1. I have negative 1 plus 4, which is 3, minus 1, which is 2. So this is positive 2. And because this is symmetrical, I will get positive 2 here. And then the last point I'm going to put in is my vertex. And this is should be the highest point. So you're going to notice we're going from negative 1 to 2. So this should be my highest point here. And I'm going to go ahead and put in negative 2 here. Okay, so negative 2 squared is 4 times a negative, which is negative 4. Negative 4 times negative 2 is positive 8 minus 1. So I have 8 minus 4, which is 4, minus 1, which is 3. So this is my vertex, my highest point, and then I should have symmetrical values on the other side. So if I were to graph this, right, my vertex, we'll say this is negative 2, we'll say this is 5, is here, and it's going to look something like this. All right, so that is how you make a t-table of values for a quadratic function when you don't know the vertex.